If you execute here this complete cell, it might be surprising for you that Python only prints here the result of the last computation. So it doesn't print the first line here. If you want to print the result of this extremely difficult computation here as well, you can make use of the print function. Functions are predefined algorithms that basically do stuff for you, and the print function does something very specific. It prints whatever you pass to it as an input or an argument. If you want to write a function in Python, you do this by first writing the name of the function, here print, then open a bracket, then type in the so-called arguments of the function, and then close the brackets. So in this case, what the print function does is actually, well, it prints the stuff that is written within the brackets. And if you now execute the whole cell here, you actually see that Python prints the result of this computation and then returns the last line of the code block that you have executed. Since we are now working in this script, we can actually provide Python with some more complex tasks. In particular, what is very useful is that you can issue some mathematical task, let Python store the results in a so-called object, and then process the object further. How does this look like? Let's do this here in a new cell. Let's define a new object called x, and we'll define it as the sum of 5 and 8. Then we can define a second object, which might be like 4 to the power of 2. If we execute this code, we actually see that Python does not return anything. Yet if we type in the x here and press enter, we see that Python returns the result of this computation here. Now, how does that work? It works through the concept of an association. An association is implemented in Python via the equals sign. And whatever is written on the right side of the equals sign gets associated with the object that is on the left side of the association sign. So in this case here, on the right side, we have the computation 5 plus 8, which is 13. And on the left side of the equals sign, we have the x. And the x here is called the identifier. It's an object that is now associated with the result of the computation 5 plus 8. And this is useful because we can process x and y now further. So for example, we can now write x times y, and this actually gives us the result of 5 plus 8 times 4 to the power of 2. In case you call an identifier or something you think was an identifier that Python doesn't know about it, you actually get an error. So here in this case, Python tells you that z is not an identifier because the name z is not defined yet. Once we associate z with a certain number or with another object, and we call z again, then we get what is currently associated with z. There are a few rules for valid identifiers, so you cannot use everything as an identifier. For example, it is not possible to use the exclamation mark as an identifier. So basically, any combination of lowercase and uppercase letters together with digits and underscores is allowed. Except for some exceptions. So for example, keywords, which are reserved for particular and important operations in Python, must not be used as identifiers. One such keyword, for example, is the word if. You notice that if you write a keyword that it changes the color here in the console, and if we try to associate if with a new object, then actually Python tells us that this is an invalid syntax. Aside from the strict rules that are enforced by Python, there are also some conventions, like for example, you shouldn't use names that are already associated with functions that exist. So for example, we already heard about a function, this function print. Now you could write something like this, print and associate it with the 8. Yet this is not very useful, because if you now write print, you actually get the new association of print, which is an 8, and now you cannot use the function print anymore. So that is something that is not very recommendable. If you did something like that in your current Python session, you want to get rid from it, you can restart the kernel, because that basically erases all the associations that you have designed before. If you want to get an overview over the associations that currently exist, you can do this by the variable explorer. If you look here, and if we execute this cell, we actually immediately see here which names are associated with which value. And that is actually a very useful thing.